So you see my screen. Okay, and let me just find that um, the last thing we did.
Mhm.
Yes. All right, let's create a shaft. And before that, I will just change all of these like internal diameter to
Yeah.
fit this one. So I can just click
Mhm.
on this edge and I can see that the diameter is 12.7. So I'll modify all of them. Now,
Mhm.
one way to do this is to use this press tool. And here you can see that I can select something and just like just like this, I can change the diameter.
Yeah.
But this is not a very good way to do it. It works, but not preferred.
Mhm.
Ideally, what you should do is go back to the sketch and just change it to 12.5 ideally.
Yeah.
Okay. Same with this. Right. Now we can create a shaft of this dimension.
Yeah.
Or before doing that, we should create like an enclosure, right? So I will just. Are you only watching or are you following along?
I'm making notes along the way.
Okay. So I should not like do something and then wait for you to finish or something like that, right?
And yeah, you can just continue.
Okay. So what do I do? I will create like an enclosure, something like a box with a bulge over here
Yeah.
to fit this. So I'll create a sketch on, let's say, this plane. Ideally, it does not matter because it's like circular, it's symmetrical both ways.
Mhm.
So let's draw something like this, leaving enough room. And I'll just drag this. Now, if you want to take like proper reference, you can use like you can do sketch dimension and then like draw from here to here. It will be let's say 30 centimeter. And similarly, you can do it for like all of them.
Mhm.
But I'm not doing that right now. Okay, I also want like if I draw a line through the middle,
Yeah.
or let's draw a center line through the middle. What I want is right now you can see the center line is not like It is not fixed to be at the center. We want it to
Mhm.
be at the center. So I will do coincident and say that this origin point and center line are matched. Yeah. And okay, and in some points you can see that I cannot select this. I can select this edge, but I cannot select this because there's no edge over here. It's smooth.
Mhm.
In those conditions, I can go to project and select intersect and like the point where or the places where the surface intersects with our plane, that is this grid over here, that will get
Yeah.
like marked so that I can select this and give it a dimension. Do you understand what happened here?
Yeah.
Okay, good. Also, instead of typing in 30, I can just click on any dimension and it will reference that dimension. So if I change this, the other one will also change.
Mhm.
Let's mm, let's mirror this thing and yep. And now I can. Okay, I don't want to cut. I want to create, let's say, a new component.
Yeah.
Okay, and component. How high should I make it? This is 100,
Uh,
so let's make it like 130,
yeah.
and let's make it symmetric because it is symmetric.
Mhm.
Okay, now this is solid, but we don't want that.
Mhm.
We want anyway. So this is solid. We want to make it hollow. So how do I do that? I can just this shell thing. So I can click on this shell and click on this surface, whichever surface you select, that will be deleted, and you can have like a shell like this.
Yeah.
So let's say a 5 millimeter shell, and yeah, we have something like this. And
Mhm.
then we need to draw a what is it? Axis. No, not axis. What is that called? I forgot. And
So is this the housing?
yes, you can make it at any shape. Like this is how you create a shell or a house. Now shape
Okay,
can be
so
whatever the necessary.
mhm,
Depending on the
that's fine.
requirement, you can change the shape.
Yeah.
I can before doing the shell, I can just go to fillet and make it more. Something like that. And start. Now let's create that axis, and in order to do that, I will go to, let's say, this component, or let's create a new component, say axis,
Yep.
and create a sketch on, let's say, this surface. And what I will do right now, you can see that the surface is like in a very awkward position. Like if I select
Yeah.
it, I'm selecting this surface instead of selecting the surface beneath it. So if I click on slice, it will slice through all the things that are above your work plane.
Mhm.
And this allows us to just draw this. Let's do this like 12.5. Finish sketch and extrude. Extrude this. Now I have to extrude it in two direction. So I'll make it two-sided. The first direction should go, okay, this should go to this face, and the other direction should go to that face. Okay.
And is this to connect? Does this connect the shaft securely to the housing?
I mean, we can reinforce it like just like where it connects, we can make another, yeah, like a cylinder with, we can make this side thicker. There are a lot of things to reinforce it.
Okay. Do you have the document that I shared last few weeks ago?
I do.
Yeah, this one. It's only this page that I need. Like the other pages are not needed. Just this one. And then it says here for the bearings that you have to locate them on a shaft and within a housing, and then making sure it's fully secured. And it will be like, yeah. And then also for the power transfer, the gears, chains, timing belt, and also to locate them on the shaft as well. And then the shaft hub connections.
Okay. Well, gear and everything is,
Yes, please.
yeah, so all of these are like securely connected to the shaft, and
Okay.
like, yeah, they are connected. Now
I mean,
they can, like, right now, because of our thing, what do we need to do? We actually did not draw it. This is supposed to be the shaft.
okay.
So let's just show you an example. So I do know what's the diameter of that thing. Like, do you have any reference drawing or anything that uh
Um, no, there's no reference, but I'll have a look if there's anything to help.
mhm, like a housing? There can be like a 100 different kinds of housing.
Mm.
Like if I like try to pull up a like actual real world example, that would be like too complex because like
Mm.
an actual car like transfer case or
Yeah.
the transmission that is like too complex. You can draw it,
It's
but
a
it will take a lot of time.
yeah. It's a housing boss. Yeah. BOSS. Yeah.
That is not. Do you see anything that you are looking for?
No, this doesn't look very familiar. I think leave the housing for now then, and I'll get back to you when I've got more information.
Yeah. Like the housing does not really like it depends on how much space you have, what other constraints you have, all of that. But like if I have unlimited space, obviously I'll just make a square.
Mhm. They've given us something. I'll just open it up. Like, okay, so um, I'll show you. And yeah, I've just sent it.
What is this?
They've told us this is a housing bus. Yes, there's nothing like this. There's nothing this complicated.
From what I understand, like this is like the thing that's holding the shaft in place in this like, like when I talked about reinforcement,
Right.
this
Okay.
is
Yeah,
what it looks like reinforcement. Like
I think that's
it's
what it is.
alright. Yeah. So let's create that. Okay, how much space do you have here? Let's increase this space and let's like if you like if you are even ever like set to create something like this, then you will have proper, like what forces is acting on it and how strong should it be. This kind of thing should be present.
Mhm.
Equal constraints to just make them equal to each other, make all the holes equal to each other.
Yeah.
Then I want reference that I have measured of this. So I'm using project.
Sorry.
No, like I want a whole same dimension as this. So I'm using project to, do you understand? Like, did I explain what project is before?
And no.
Okay. So let's say this, I'm working on this surface. What project does is you can, so you can see it from here. And what project does, it creates like a shadow of whatever you selected. So
Right.
so that you can reference it. So if you look at it from top, whatever you like a shadow of it. Okay.
Mhm. Got it.
All right, now we want the same thing on the other side. So how do I do that? We can just create a construction plane, mid plane from here to here. So
Mhm.
like I go here and select mid plane and then select the two surfaces and I have another surface at the middle of them. And then mirror bodies, mirror this. Hmm. Yeah, now there's a problem that this shaft is going all the way to the back, but it should only go till here. So I will
Yeah.
use this combine, but I'll use cut here. So I'm cutting it like this. Keep tool should be on, otherwise this thing will be hidden. Combine. So the target body is the body that needs to be cut or that will get edited, and tool body is the bodies using which this edit is happening.
Yeah.
And you can like select something and then press V to hide it. Okay. Okay, now we have these holes. Now let's create some screws.
Yeah.
Yeah, actually,
We could just insert the screws from the already downloadable part.
yes, we can.
Mhm.
So these are M4 screws. So let's go here. We want hex. Let me just stop. So we want like step file. Oh, no. And then we have this. Rotate it in correct axis and then say the midpoint of this circle should be equal to the midpoint of this circle. And then the match. Then I can just copy this multiple times.
Yeah.
Copy this body. Select this. Create copy. Point to point and then create copy. Origin point would be. So you see that when I hovered over this surface, I can see the correct circle. But when I go to select that surface, some other surface is getting selected. So what I can do, when I see the circle, I press Control and then I can select this. Okay. Similar
Yeah.
way, select that. Another copy, and then a mirror object. This for and just put these in the correct component so that I can just copy this. Copy. So instead of copying like three other, like four different bodies, I can just copy this component.
Yeah.
That's looking better. So that works.
Yeah.
Anything else that needs to be done?
Yeah, so I'm gonna send you something, and I just wanna confirm, has has these bits been covered?
Place it on a shaft. Yes, we have. Well, we did not place it. We created the shaft at the very end. So
Mm-hmm.
everything was already placed.
Okay,
Like we
awesome.
placed it on an imaginary shaft, and then after that we created the shaft.
Okay,
You
got
remember
it.
what we like using this like joint command, joint tool. We like
Mm-hmm.
placed it on
Yeah,
the correct position, but at that
yeah.
point there was no shaft.
Mm-hmm.
Yes, they are inside the housing. It is secured. Yes, we have like it is secured and what else? Ideally, okay. So right now this thing can just move. We don't want that to happen, right? So we want to right
Um,
click here and we want to ground to parent. So now they don't move. Similar with the these things. Now this is not necessary because this movement is not like you screwed it in, but this is just not important.
okay, so you just have to ground it to make sure it doesn't move.
Yes, but this movement is not like a part of the design or anything like that. So it is like no one expects you to just drag it around.
Yeah.
So
And then there's the stuff about the power transfer, which I've sent you as well. On yeah, and that's basically what we need to accomplish.
so how is power transfer? Using either pulley or like a belt system or
Um,
like a gear.
it says it's how the power moves from a rotating shaft to another one using gears, chains, V belts, and pulleys, and timing belts.
Mhm.
Um,
I understand what you said. Now, I have shown you how to create these things.
mhm.
I haven't showed you how to create a pulley, like create the belt, sorry. But I'll do that now. But the other part of this is which, like, there are different things to use, but which one to use when. That is the theory part. Like when you are trying to like transfer power at 90-degree, you would use, let's say, like a conical gear, yeah, something like that. Uh, Now, this is theory. Um, Now, do you want me to show how to create them? Because most likely you won't have to create them. It will be available for you to download.
And no, then yeah, don't need to create them. Plus, I think I know how to create this shape anyway.
Mhm. It's just, like, do you want me to just show how to create it? Like, just in case.
Um, yeah, I think it'd be good to know.
Okay, let's just create a new thing. I will draw, let's say, two of this on top of each other. Now, in order to create that like edge that is at an angle, we can use chamfer.
Mhm.
So something like that. Now you
Yeah.
can set the angle, but I'll just make it 45-degree.
Yeah.
And then to create like the gear teeth, you
Mhm.
can use what can you use? Yeah, you can use. So there's this. And yeah, this works. So you can do this tangent plane. So you can like create a plane. So in order to create the teeth, you need like a plane surface, right? But this is circular or like
Mhm.
curved. So you can just do plane, draw on this plane, and I will just do project, intersect. I just want this point and this other point. Okay. Then I draw a rectangle, make the center point of this point as the center of this rectangle so that you can like do like that and it won't move out of the way. Then give the dimension of the teeth size, maybe 1.5 or something like that. Doesn't matter. Well, matters in actual use case, but in our use case, no. Uh, make it symmetric and then join. And then now we can just do circular pattern out of this axis is that and 50.
Yeah.
Okay.
Mhm.
Now again, if the load is too high, then you won't have these straight cut edges. You'll have helical things.
Yeah.
Yeah, these kind of things. So in a car,
Oh.
mostly these are used. So they are not straight. They are at an angle to
Mhm.
make sure that they don't break off if like if you downshift a little too aggressively. Yeah.
Yeah. And there's also another thing. So,
Okay, okay.
um,
So and like which gear, what you use where, that is theory.
mhm. So we have like, so I've just sent you something. So we're tasked to, we're basically given the pulley and the gear in the exam to download,
Mhm.
and I just sent it on messages.
Basic. Mm, okay. Can't spin loosely or make you get it. Can't spin loosely or follow. Yeah, that is simple. Like you don't have to create anything. You just like assemble it.
Yeah. Could we go over that as well, please?
Mhm.
If you want the part to make it easier, I can send it you.
Yeah, that will be better.
Yeah. They've only given us the pulley, not the gear.
Yeah, we can create that.
Okay. I'll send you the pulley. Yep, just sent that across.
Mhm. So I'm creating a new design. Let's say let's name it assembly. And then I can drag and drop. Okay, yeah, I can drag and drop this pulley inside assembly. So it will
Mhm.
create like a new component. And okay, am I allowed to make any changes to this thing?
Um, Let me just have a look. Yeah, you can make changes to it.
Okay. So that's because this is smooth surface. Now, however, like another criteria is that it should be secure. It cannot like slip around.
Mhm.
And in order to make sure that it does not slip around, we need to create like a key or a gear inside it or something like that.
Yeah.
Okay. So well, let's open this pulley thing. Instead of okay, I'll just work off this design only instead of creating another one. Okay. So I will go here and draw like a simple key over here. Say another one on top. I want to make sure that they are aligned with each other and also that they are touching the circle. Equal height. Let's say 1.5. Yeah. So now we have like a key. So if our shaft also have this key and it like connects, then it won't be slipping around.
Yeah.
Okay, so another thing that I can just do everything in this design only, but just to show you, if I save it here, since I referenced it from other design, so in this file,
Mhm.
you see that I have like a warning sign. If I click on this, it will update to the latest version. Okay,
Cool.
so
Yeah.
that's how you link two or three or multiple different files. So,
Mhm.
all right, now So let's create a sketch, and now I can use this. Mm, Let's say 100 so here, and this side can go to 41 plus 100. Okay. Now, in order for this to rotate,
Mhm.
okay, what I need to do,
So is that the shaft through the circle?
yes, but this does not need to go all the way. It can like
Right.
stop after. Actually, yeah, let's not do it like that. Let's not. Instead of going through all of that, I'll make only one side, and that side should end over here. So the keyed part should only be present till this. Okay. And everything else should be like smooth circle.
Mhm.
And I will use this 2 point circle to make that. And feature. Okay, let's just create another of that. For the other side, sketch. So I don't want it to start from here. I want it to start from object. So it should start from here, and it will be minus 100 because it's going in the other direction.
Mhm.
And they are all like joined. So like if I hide this, this is like one continuous thing. It's not like broken into three parts.
Yeah.
Okay. Now we need, okay, now like rotationally it's secured, but it can still slide left and right, right? So we'll need to make
Yeah.
something that stops it from sliding.
Yeah.
And to do that, what can we do? We can create like a washer and a nut setup.
Mhm.
So again, I'll go back to the sketch and I'll create another like pixel scale. Like how big should it be? 20, 28. Yeah. So yeah, let's say there's like a structure like this that helps it secure.
Yeah.
The same thing is present on the other side. Let's create like a mid plane between this and that. Oh, there should be a new body.
Mhm.
So, oh, So the mid plane should not be between these two, it should be between this and this surface. Because like it's less over here and more over here. Like this. We have some structure to make sure that it does not slide left and right, and we have some structure to make sure that it does not like rotationally slide. So that means it's secured.
Amazing. Got it. Thank
Yeah.
you.
Okay, another thing that we can do to like okay, so right now this only secures based on friction, right? But this is not very ideal. Another thing you
Mhm.
can do is have a plane, so it's like cutting mid. So you can like create a circle over here. Let's say I'm 4 and like put a screw in between, and that screw will actually secure it.
Yeah.
Something like that. If you want to make it like exactly at the center, then you'll have to go to intersect this and that. And let's create like a construction plane. Okay, if I'm going too fast, then also let me know. Okay,
Yeah, it's fine because I'm gonna watch the recording back anyway.
okay, I got it.
Thank you.
So slice, and then I'm using this midpoint to point, like to actually place it at the middle.
Mhm.
Mm. And then it will just be a hole. And you can like long press on like right now you see that I cannot select the actual profile or the sketch because it's under some other things. So I can long press. Oops, not like that. So I can long press and I'll get a list of all of the things that are like overlapping. Then
Mhm.
I can select from here. Okay. How much should it go? It should go symmetrical and all. So it's a through hole. Or wait. Yeah, maybe no, it's not a through hole. It's just one side. Okay.
Yeah.
Like depending on the design preference, okay, if like, either way works. Even a through hole works here. You just have to you'll need just a bigger screw. That's all. Like a screw on top and the nut at the bottom and then secure it properly.
Yeah.
Okay. Okay, and right over here, like nothing is mentioned about housing. Is anything mentioned about housing? No.
No,
Nothing is
no,
mentioned
not
about
home.
yeah, but you can like create if it is mentioned, then you can just create something like that. Okay.
Got it.
Like the shaft goes create something a random square or a depending on what's given. Create
Yeah,
some
and that's
structure like that.
different. Mhm. And then the last one is shaft hub connections. So I've put it into ChatGPT to summarize it, but yeah, I just sent it you now, and it makes it a bit clearer on what to do in on that task.
This one, right?
Yes, this one, please.
You have it here. You want to put it on a shaft, okay? You want that gear to spin with the shaft, okay? So you can create like a keyed structure like this. Just instead of a pulley, it will be a gear
Yeah,
to
exactly.
make sure that it does not slip, it does not
Mhm.
slide off. Okay, you need to create like just this structure instead of a pulley. It's a gear, so you need to create this also. to ensure that it does not slide off.
Mhm.
Place it here, shaft, and it's the same thing. Place the gear or pulley or bearing on the shaft and make sure it does not slip. Yeah,
Yeah.
same thing. Slots between the shaft and the gear. Yeah, so there are different ways you can achieve the same thing. So over here, if I look at it, um, okay, so here we have like that key structure, but there are several other ways you can uh, like achieve the same thing. Imagine if you have like a rectangle over here, okay, like a rectangular piece, like it's a cross section, so it looks like a rectangle, but actually it's like a cylinder, and there's a like a spring attached at the bottom of that cylinder. So whenever it slots in place, the spring lodges and it like fixes it to place.
Yeah.
Do you understand what I'm talking about?
Yeah. So this bit would fix it into place.
Yeah, yeah. This bit this works, but
Mhm.
at the end, what it like it's but this is not the only way this works, right? There are many other ways that you can use to achieve the same thing. So it's
Mhm.
talking about some of those ways.
Okay. Cool.
So
Thank you.
instead of like having this structure, you can have a screw and screw it directly into the shaft,
Yeah.
or you can have like the thing that I said, a spring-loaded mechanism, so that when it fits in place, it snaps.
Yeah.
Uh, and there are also like press fit things available, like ready-made things available to do the same thing. Mm, yeah, that's it.
And then that bit will be covered.
Yes.
Awesome. Thank you.
Mhm.
And
I
I
don't
know
see
we're
anything
running.
new over here. It's just the same thing that I did before. Just with a
Okay.
like instead of a pulley, it says like a gear or pulley or bearing. Anything.
Okay. Yeah. And I know we're running a little bit over time, but do you have a bit of time to cover simulation?
Oh yeah. Yeah, let's do that. Yeah, why not?
Is that okay?
That's okay.
So I'm gonna send you this question. So we're given something like this. This is just an example in the exam, and um, yeah, and we have to conduct like a stress sample through stimulation.
Okay. No, I don't work with stress analysis a lot, so yeah, let's see. But I understand. Let's do that.
Thank you.
All right. So first of all, what the so I will go to physical material. and check what materials we have.
Yeah.
So by default it's steel. So
Mhm.
maybe the shaft is steel, but this thing does not need to be steel, right? It can be
Yeah.
something a little metal, aluminium.
Yeah. Aluminium.
Oh, I cannot. That is not that. Hmm. So okay, so this component, I'm not. You see that this link sign means that I'm referencing it from some other file. So in
Mhm.
order to, I cannot edit it in this file. I need to go to this other file and then go to physical material and edit this material. Okay. I can just like break that link and do it, but
So why do
this,
we need to change the material? Like, can we just not leave it the same?
yeah, we can. Why not? Like generally material will be given, or if it's not given, it's like just says use.
Yeah. Does it just make it easier to keep it the same?
Yeah, it does not really matter.
Mhm.
Okay, so let's go to, let's save this thing.
Simulation.
And let's go to simulation. Let it go. All right, and we want stress simulation, static
Yeah.
stress.
Mhm.
That's the easiest. So we will need to, add some constraints saying that, let's say this surface. So what is ideally happening? These two surfaces over here are fixed, and all the
Yeah.
load is placed on this middle thing, and we are trying to figure out if uh, like this shaft can hold it or not, or we need a thicker shaft or anything like that, or we need to reduce the distance.
Mhm.
So yeah, so let's make this fixed and add another constraint and make this also fixed. You'll see that there are like different other constraints.
Yeah.
So if you want like a surface that can slide freely, then there is like, you will see that there's this frictionless or other things. Now let's put some load. Load should be on top here, and we want load coming from top. And how much load?
It says 900, I think. Oh no, no. The load for the timing belt is 450 N, and the V belt pulley is 900 N.
We only have one pulley. Should I make another one, or just
Yeah.
use the only the V belt one?
Uh, you can just use one of them for now.
Okay, so we have a V belt. So we will use the 900 Newton.
Mhm. Is this the V belt? Is this the V belt pulley?
Yep, it's a V. I think.
Yeah.
Yeah, timing belt pulley has like gear teeth.
Mhm.
That's what we have, right?
Yeah.
Sure. Whatever you understand. It's like that. Like generally, but let's put some load here. Okay, so it's 900 Newton and it's down. There are several options over here that we can choose from. Like this is a curved surface, so normal to a surface, it does not work over here. But yeah, everything else is going to change anything else. And are you missing anything or so that's it?
And we also have to, so this didn't conduct the stress sample though.
No, no, we did not yet do the test. I'm just trying to figure out if we need to do anything else before
Okay.
starting the test.
Mhm.
Take the constant. So, okay, we need to define this automatic contact to make sure that it knows that like they are in contact. So, like it does not just slide through it. That makes sense.
Mhm. Yep.
Mm. So, let's do that. So, that should be it, right? Yeah. And it also generates like the computer mesh. Yes. So, it also creates a mesh that like like what is a mesh? A bunch of triangles covering your body, like covering the body that we are trying to work with. And by
Mhm.
calculating the like stresses on those individual triangles, like how much load is in the individual edges of this triangle, like it calculates the stress on the whole body. If that makes sense. But again, theory not needed.
Yeah.
So let's solve this and see. It says that okay, before doing anything, here's a pre-check, and it says that everything is good, and let's solve. It will take some time to do it.
No
It's a
problem.
fairly simple one, but the thing is that you cannot do it on your local system. It like sends it to cloud and does all the calculation and sends it back. So it
Mhm.
takes some time.
Yeah.
Uh, Before that, like while it does its thing, I will also I think create a like we need to export this thing. I think did they mention anything about that?
Yeah, they said convert and put it into a PDF file.
Um, yes. Uh, yeah, it's medium alloy steel, so
Mhm.
it's good. Assume the shaft material is steel. It does not mention anything about the pulley material, and so the use ideally what should happen is the pulley should be we should make sure that the pulley is of a lighter material than the shaft, so that there is
Mhm.
less load because of the weight of this pulley.
Yeah.
So ideally you would make it of aluminum or something like that, not steel, which is heavy.
Okay.
And we cannot do anything before it completes. Like, no, wait a minute. What? Anything else, or should we just wait? Oh, okay,
And
okay, done.
and then we have, I think you turn the safety off as well.
Safety off. What?
Yeah.
What do you mean by safety off?
Because they told us in class, like when the safety is on, it doesn't conduct the proper sample. So would you for this exam question, would you leave it on or would you turn it off?
I don't understand what you mean by safety.
Can you see there? It's like a drop down icon that says safety factor. You just click that. Click on stress, please. Yeah, I think this is what we have to
These are
put it
two
on.
separate things. Safety factor is uh, so like there's a margin of error, right? And like again, I don't really work with this, so I'm not sure. But like, will it break or not? If the safety factor is too low, then there is a high chance that it will break. It will break. So
Hmm.
if the safety factor is over 2 or 3, then it's a good sign that it won't break off or bend in load. But what we are concerned with is stress. So safety factor, that does not matter. Stress, and I think it's one miss. I think.
Yeah, it is that. Yeah,
Yeah, that's one.
one. Yeah,
Convert a one is just a PDF file. Okay, yeah. So you just make a PDF file out of it. Yeah.
and you just save this as a PDF.
Yeah. So again,
Mm.
you see that it is exaggerated.
Yeah,
Actually, like exaggerated for our understanding,
yeah.
but actually it won't like bend that badly. You can see like a subtle bend, a little bit. That is
Hmm.
what the actual bend is.
Okay.
Okay.
Yeah.
So you
Thank
can
you.
like change between like this exaggerated version and the actual version.
Yeah.
And and you can see like there are other things like displacement, like how much change you can see that like because of the bend, the pulley moves down by like point three of a millimeter. So it's very less.
Mhm.
Stress. Okay. Now the question is, if needed, you can do all of that, but
Okay.
thing that is needed now, can we create a report from it? Yes, we can. Is this report needed?
It doesn't specify. It just says that convert it into a PDF file. I know the
Okay,
report's
then
not
no. The report, no report.
needed.
Just for, so you know, it creates a it creates a report, and you can send it as
Yes, pretty good
that.
to have.
Mm. And anything else that is useful? Not really. Okay, yeah, that's it. Oh, there is
Okay,
this
great.
report also. Yeah, I don't know. I'm never exported it, so let's see what it is.
So, how would you save the stress as a PDF? Just the normal
Just
way
a
you save.
screenshot. Just a screenshot, and
Okay. Mm.
because that's what they ask, right? They don't do not want any report or anything. That they just want to
Yeah,
see that you have done it.
yeah, just the PDF. So, just use snipping tool. Um, and yeah, could you send the link again for payment because
Yeah,
we
sure.
lost it?
Um, just wait a minute. Yeah, no clue what that is, but we don't need to. So,
Mm.
so do you want me to send any of these files to you, or it's all good?
Yes, please, if you could send that and the recording as well.
Okay, let's do.
And if I wanted to learn the basics of CAD as well, like all the tools and all the functions, do you cover that as well?
Yeah, I do that.
Cool. I think next time I'll learn that.
Fine, no problem. What happened? Files went black. Yes, this is me. Oh, so paper. We use paper, right?
Yeah.
Do you know how to disable this two-factor authentication thing?
No, I've been trying to do it as well. You
Yeah,
can't.
I don't see an option to do that.
It's worth it on Microsoft because you have to verify your email as well.
Yeah, that's what it did. It verified my email with like a Q, what is it?
Yeah.
OTP. Yeah, where do I send? Yeah. How much time did we do? We did almost 1.5 hours.